The lithium iron phosphate batteries and the solar charging system that I installed 6 months ago have proven very reliable. It's now time to start removing the original and backup lead-acid battery system. In order to eliminate the lead-acid batteries, first I need to tie in the electronics from the engine and from the windlass to the lithium iron phosphate system. There are several drawbacks to using a lead-acid battery system. The batteries are very heavy and they do require regular maintenance. The water levels inside the battery must be monitored and topped off. Also, the usable amp hours with lead-acid batteries is about 50% of what it's rated. So if you have a 100 amp hour battery at 12 volts, you can only use approximately 50 amp hours out of that battery. The lithium iron phosphate batteries have many advantages over a lead-acid battery. They weigh approximately half as much, they do not require any maintenance, and they have 90 to 95% usable amp hours. So if you have a 100 amp hour battery at 12 volts, you can use approximately 90 to 95 amp hours, whereas with a lead-acid battery, you can only use approximately 50 amp hours. El Jaleo originally had 5 lead-acid batteries. 3 were located above the engine compartment, 1 in a hanging locker just to the left of the engine compartment, and 1 up front as the primary battery for the windlass. The first step is to remove all of the lead-acid batteries so I can tie all of the systems together. The next step was to remove all of the lead-acid battery cables. I didn't want to leave them in place because it could create a short circuit situation when the lithium iron phosphate system is tied in. Lithium iron phosphate batteries are capable of outputting enormous amp loads, and it would have instantly fried a good portion of the system if any of these two cables had come in contact. On the original lead-acid battery system, each individual battery had its own dedicated switch, so I had to go through and make sure and remove all of the positive terminals from those switches. When the switches had been disconnected, the wires could finally be pulled and removed. With the top 3 sets of battery wires removed, now it was time to remove the final set. And this was for the battery in the hanging locker just to the side of the engine compartment. There was one final set of battery cables in the original lead-acid battery system, and those are up at the very front of the boat, and that was a battery that was dedicated for the windlass. I will be replacing that battery with a lithium iron phosphate battery, and it'll be tied back to the original system. Therefore, I'll be leaving that set of battery cables intact and reusing them. At this point, it should be safe to tie the two systems together. All of the electrics for the engine are tied into the overhead panel, so I decided just to go ahead and reuse that. It should be as simple as tying one line between the lithium iron phosphate system and that overhead panel. Fingers crossed. I have been buying all of my electrical wiring from a website that has very reasonable pricing. Unfortunately, they've been out of stock for quite a while on the one AWG wire. So in true worst marine fashion, I had to go through them and get it at about twice the price. And I ordered 10 feet so I could properly route the wire back to the bus bar. And I only received 6 feet, so it is too short. Since this wire was cut shorter than it should have been, I will have to replace it at some point in time, but I do need a temporary line in place, at least so I can run my engine in case I have to. Both ends of the wire must be secured with lugs. Crimped on lugs are a good way of making sure the wire is secure and doesn't come undone. Sometimes being 6'1" and overweight is kind of a drawback. Some of the spaces on a sailboat are pretty tight to get into. Prior to making the final connection, I decided to disconnect the alternator from the system. I'm not exactly sure what the output voltage on the alternator is, and I'm not exactly sure what it should be to put power back into the lithium iron phosphate system. The bulk phase on the solar charge controller is 13.5 volts, so I'm guessing that's what the output from the alternator needs to be, but until I get confirmation on that from Dragonfly Energy, I'm just going to leave the alternator disconnected. After the final electrical connection is made, it's now time to go ahead and give the engine a try. Since it's been over a month since I've started the engine, I go through all of my pre-engine startup checks. I check the raw water strainer, make sure I open the valve to get cooling water to the engine. I also check the oil and the coolant levels. Alright, so I went through all of my engine checks pre-startup, and I think we're ready to go ahead and give the engine a try and see if it will start on the lithium system. So I'm going to go ahead and turn our selector to the engine bus, and I've got the alternator disconnected until I can get that set correctly. And let's see, let's just get our Victron app going here so we can see what this does to our power. Okay. Apologies for the dog food mess. That morning Neptune had decided his breakfast wasn't good enough for him, so he spread it all over. She's in neutral, the kill switch is down, and let's see what we've got. Cross your fingers that everything works as intended. And I should be able to tell just from the glow plug. And I don't. Oh yeah, we got that. It's definitely drawing some watts. Ooh, almost had her. And we know that our new alarm works because we just heard that chirp. And we have a functioning engine. Tune in next week to see the completion of this project, I do have the one battery for the windlass, and I do need to figure out a way to get the voltages the same with the existing battery bank. If there's more than a 0.1 volt difference between the two, it could be a problem when I hook the new battery into the system. So tune in to see how I figure out how to do that, and hopefully I can get the alternator completed as well. See you next week.